This problem is going to look at a classic computer science, computer engineering interview question that usually tests the efficiency of how one programs or the thought process one uses when setting up a program. We're not going to get into so many of the details about optimizing it for efficiency or the different ways we can code it, but it's sufficient to say there's multiple ways to go about solving this. We're just going to come up with one method that works. So we're going to create a function that takes in a scalar integer and then is going to do different things depending on its value. So if the value we're given is a multiple of 3, we're going to display or print fizz. If it's a multiple of 5, we're going to print or display buzz. If it's a multiple of both, then we're going to show fizzbuzz. And if none of those are true, then we're going to just show the value of the integer itself. We're going to work out the problem and the code on paper first as a flowchart, more conceptually, before we move into MATLAB to actually start coding it up. So this is a problem where we want to make a function, and we're going to be given some value that is going to be a scalar integer. So it's a scalar, it's an integer. I'm just going to call it x for lack of something better. So just putting these reminders here, the input is scalar and integer. So we're going to do different things depending on the value of x. So let's start thinking about the different things we need to be able to do with this. So we're going to either print the value of x itself, or fizz, or buzz, or fizzbuzz. All right, so let's take this x and we're going to need to make a decision. So let's see what our first decision could be. Well, in the order it's given to us, is it a multiple of 3? So is x divisible by 3, let's say. Right. So that's the same thing as saying it's a multiple of 3. So is x divisible by 3? I'll clean this up a little bit. Again, this is just conceptual right now. In the code, we'll have to actually check, is it divisible by 3? So if this is true, if it's divisible by 3, then we should print fizz. All right, that's the true branch. And then if it's false, well, then there's other things that we're going to have to do. All right, so if it's divisible by 3, we're going to print fizz, or display it to the command window. If it's false, we can check, well, let's look at the next statement. Is it a multiple of 5? So is x divisible by 5? If that's true, if it's divisible by 5, then we should print buzz. So I'll just put here buzz in quotes, but that means print buzz. And if it's false, that means as we go through here, x is not divisible by 3, it's not divisible by 5, so therefore we would print x itself. And this is actually a rare case where we are not outputting a variable, we're not returning a variable, we're just doing some operations and then it ends. It doesn't return anything. So this might also be known as a subroutine in other languages. Usually not the case that we're not returning a variable when we are writing a function though. So looking at the flowchart, we kind of have a problem here because we don't have any case where it's or anything built in here if it's divisible by both 3 and 5. We kind of programmed ourselves into a corner, at least on paper. That's why it pays to look at the flowchart first. Nowhere here are we printing fizzbuzz because the way that we have our logic, we can't determine if a number is divisible by both 3 and 5. So actually the structure we have here is not going to work for us. So I'm going to kind of start over here. This is not good, the way that we did it, because we check for if it's divisible by 3, then by 5, kind of separately, but we can't check for simultaneously, is it equal to, is it a multiple of both 3 and 5? So really at that first step, we need to change the way we think about this. We could check this up front. So is x divis by 3 and 5? So the order of these ifs matters, the order that these decisions matter, so that we can check this. So we can check, is it divisible by both 3 and 5? If that's true, okay, now we've captured this possibility, and we can print Fizzbuzz. And if it's not divisible by both 3 and 5, that doesn't mean, so we're checking, is it divisible by both? That doesn't mean it can't be divisible by one or the other. So we can come to another decision here. Just because it's not divisible by both 3 and 5, we can now check, is x divisible by 3? So look in the order that we are doing our logic. We've already checked at this point, is it divisible by both 3 and 5? So when we come over here, if that was false, is x divisible by 3? If that's true, well, we already know at this point it's not divisible by both 3 and 5. So if it's divisible by 3, then it is not also divisible by 5, because it would have been picked up in that previous decision that we made. So if it's divisible by 3 at this point, the only possibility is printing fizz, because we know it can't also be divisible by 5 if we made it this far, the way our logic is set up now. So it's not divisible by both, but if it's divisible by 3, then we can print fizz. If it is not divisible by 3, then we can check, well, divisible by 5. And it's really cramped in here, but we'll get the point across. So is x divisible by 5? Now, if that's true, well, again, we know, we've already tested kind of twice now, it's not divisible by both 3 and 5. That's the only way we got to this branch. It's also not divisible by 3. That's how we got to this branch. So if it's divisible by 5, that means that we can print just buzz. And so that's if it's true. And if it's false, well, so what do we have here? We've looked at x. It's not divisible by both 3 and 5. It's not divisible by 3. It's now also not divisible by 5. So it doesn't meet any of those conditions. So if this is the case, then we can just print the value of the number itself. So again, part of the value of doing the flowchart is that we haven't put anything to code yet. We're not getting wrapped up in the syntax, but we can think about the logic and conceptually how the program is going to flow before we get to that point. So let's think about this with some test cases just in the abstract through our flowchart. So let's just look at what if we put in 3. So if x is 3, let's see how our program is going to work. Is 3 divisible by both 3 and 5? That's no, false. Is 3 divisible by 3? Well, yes, that's true. We're going to print fizz, and then we're done. Well, if we have 5. 5, is 5 divisible by 3 and 5? No, it's not divisible by 3, so false. Is 5 divisible by 3? Again, false. Is 5 divisible by 5? That's true. We'll print buzz, and then we're done with our function or our subroutine. What about a number like 7? So is it divisible by both 3 and 5? No. Is 7 divisible by 3? No. Is 7 divisible by 5? No. We're going to print 7. So that makes sense. And then, like, let's say 15. So is 15 divisible by both 3 and 5? Well, that's true. So we're going to print Fizzbuzz. So thought about some of the different possible cases here and how the flow is going to work. So it looks like on paper, this should work for us in some of these test cases. Again, we haven't written any code yet. Now we need to translate this into code that we're going to put into MATLAB, and then we can try our simple test cases again to make sure not only does the conceptual part work, but does the code part work. Now we can start the coding portion. So this is supposed to be a function. So we'll use function. And what are we returning? This is actually a rare case where we are not returning a variable. We're just going to be printing things to the command window. So we can put, and we have to put here this empty brackets. We're actually not returning any variable. Again, this is uncommon that you're going to come across this, but like we're seeing here, it can occur. And then the name of our function has to match the file name, which I've already named CompSci 200 L03 fizz. And then the name of the input. In this case, well, in our flowchart, we called it x. I'll just stick with that here. So x is going to be the input. X is a scalar integer. Our program is not meant to work otherwise. We can put things in here to detect errors, or if something came in that was a decimal or that was a non-integer or a vector. We're not going to worry about error catching though. We're just going to assume we're only going to be using our function properly with a scalar integer as our input. And this is a rare case too. We are printing to the screen as part of our function. I'm going to put a CLC here to clear it every time, but usually do not put. All right, so anytime we make a function, almost anytime, we never want to clear, we never want to close, we never want to clear the screen. So don't use the clear, the CLC, or the close all typically. This is a rare exception to that because we're printing. I want to make sure it's printing kind of the freshest thing every time. So that's why I am, in this case, clearing the screen. But typically, do not put a CLC in a function. In a script, yes, put CLC, put close all, put clear at the top of that. Almost always, that we're always getting a fresh start. All right, so the kind of skeleton is made. Then we're going to return at the end. So we have those put here. Now we can look at the flowchart. All right, so starting at the top of it, we are given this x. That's coming into our function. So the way we wrote our flowchart, the first thing we're testing is x divisible by 3 and 5? So we've looked at this before a couple of times, but we'll, when we're looking at divisibility, what we can use is the mod function typically. So let's look at a number like, let's just say x is 6. So we want to test, is it divisible by 3? So we can use mod, and then the number, and then 3. Mod is going to return basically the remainder when we divide the first number by the second number. So when we divide x by 3, what's the remainder? And it's 0 because 6 divided by 3 is 2, no remainder. So when mod returns 0, that tells us that the first number is evenly divisible by the second number. So 6 is evenly divisible by 3. So we can put that here. So it's a decision, so we need to make an if block here. So if mod x comma 3 is 0. So if the mod of x comma 3 is 0, then this will evaluate to true. So like in this case, mod x comma, when x was 6, it evaluates to 0. 0 does equal 0. This statement is going to give us 1. But for this first block that we set up, this first decision, it has to be divisible by both 3 and by 5. So let's look at the mod of, well, we're still looking at 6 here. So 6 and 5 is remainder 1 because 6 does not divide evenly by 5. So I'm going to put an and mod x comma 5 equals 0. So again, this is that first decision, that first diamond shape. Let's just see what happens here. So when x is 6, I'll just redeclare it here as our little test. This is going to be false or a 0. This first statement, though, is true. So I have a 1 and 0. 1 and 0 will evaluate to 0. So when in the case when x is 6, this statement should not be true. It will not evaluate to 1 or true. But if it is true, then we want to, I'll use the disp here. When it is true, we want to display Fizzbuzz. So we're going to print that. And otherwise, when it's false, we're going to go to that next test. So I'll put stars there just to remind us to fill that in a second. All right, so this is that first block, the decision block we came to. Is x divisible by both 3 and 5? When it's true, we print Fizzbuzz. When it's false, well, then we're going to go down this false branch, which we'll get to in a second here. All right, let's go down the else. So when this statement is false, we're now going to that next decision block. is x divisible by 3? So it's a decision block. We definitely need to put an if in here. So is mod x3. So is just that true? Is it divisible by just 3? If it is, then we want to display just fizz. Otherwise, again, I'll put some placeholders here. Otherwise, we'll go down that other branch that takes us to another if statement. All right, so let's go down that other branch. Is it divisible by 5? Right, so again, notice that first test was there's this and here, is it divisible by both? If not, is it divisible by just 3? If not, is it divisible by just 5? So if it's divisible by just 5 at this point, then we're going to print or display just buzz. And otherwise, we're going down that false branch. Well, the last thing here is we just display the value of x itself. And then we have to end that block. Right, and the way it's coded here, it actually has everything we need. Every piece of the flowchart is accounted for in some way. And again, it's not necessarily the most elegant way to do it. We're not interviewing for a programming position, so we don't have to overthink this one. We need something that works. Actually, we don't know it works yet because I haven't tested it. So let me save this and test it before we go and try to change anything. Make sure that we didn't mess up anything or that the logic we thought was right in the flowchart stage remains right when we're in the programming stage. All right, so let's try different numbers here with our function. All right, so different values of x. So like the ones that we were testing before, just in the flowcharts phase. So let's put in 3 for our input. It returns fizz. So that's correct. 3 is divisible by only 3. It should give us fizz. Well, if we put in 5? Just buzz, so that's good. Well, if I put in 4, it's divisible by neither 3 nor 5. It gives us back 4, so that's good. 15, which is divisible by both 3 and 5, gives us Fizzbuzz. And then that 6, divisible by 3 but not 5, gives us just fizz. All right, so it looks like our function is doing what we want it to. Try just another one. 8 is not divisible by 3 nor 5. It returns our number. 30 is divisible by both. Gives us Fizzbuzz. 31, divisible by neither. It gives us 31. All right, so we could test numbers all day. It looks like the program that we wrote does work. Now, yeah, I just want to review a little bit of the differences here. We followed our flowchart, and we have these nested if statements here, and that's okay. We could probably improve on that if we needed to. The function in this uncommon case does not return a number or does not return a value. So I have these empty brackets here. Almost always you will have at least one variable name in here, if not multiple. So this is uncommon for writing a function. The function name, CompSci200L03 fizz, takes one input or one argument x, and x has to be a scalar integer. Because, well, this will actually probably work even if it's not an integer, because it still follows the rule, because 2.5 is not divisible by 3 nor 5, so it just returns the number. So actually that's okay. But let's see other things we're not prepared for. So what if we give it a vector? Well, it doesn't work correctly, but it's also not designed to. So the function is designed to only take a scalar. We gave it a vector. Well, it crashes out on us. But that's not a big deal, because again, it's only designed to handle integers or scalars. We're using it wrong if we put in a vector. So that crash, that error is not a big deal for this function. All right, now I'm going to copy this logic and put it below. Actually, I'll cut it. So this is kind of version 1 of the code. This is not the only way we could do it. I won't make a new flowchart here, but there's kind of slightly more efficient ways that we could have done this. So let me just kind of play around here. So let's check, is it divisible by 3? All right, so if it's divisible by 3, then kind of the first way we wrote the chart, I don't want to, but thinking ahead, I don't want to jump and just make it buzz, because if it's divisible by 3, I can then also check, is it divisible by 5? Right, so this is underneath it. So inside this if, it is divisible by 3, it is divisible by 5, therefore it must be divisible by both 3 and 5. I'm going to display Fizzbuzz. Otherwise, well, I'm still in this if it's divisible by 3, then I checked if it's also divisible by 5, and this time it's not. So now I can display just fizz. I'm going to use an else-if, and we'll see why in a second here. All right, so the original statement was, is it divisible by 3? I checked if it was also divisible by 5 inside or not. Now I can check, well, is it divisible by 5? By the nature of an if block, if the if was false, then it goes on to the else if. So in line 11, I can't get to line 11 if the number is divisible by 3. So by the nature of the if block, if I reach line 11 and I ask, is it divisible by 5? Well, then it is automatically true that if I reach line 11 and that's true, it cannot be divisible by 3. So I here can display then just buzz, because automatically it is divisible by 5, but not 3 to get to this else if. And now I can have an else here. So the if was it divisible by 3? The else if was, is it divisible by 5? If both of those are false, the number is therefore not divisible by 3, nor 5, nor 3 and 5. So in that case, I can display the number itself. So this is an alternate way. It's a little bit simpler coding-wise, and we could have come up with this flowchart as well if we started with the first choice being the 3 and then thinking about the possibility of it being divisible by 5. If you go back to see how I first was writing the flowchart and kind of got stuck in a corner, I could have corrected it by not just erasing the whole thing and instead doing this modified version. But I decided to, in the flowchart we're using over here, to use the first test being, is it divisible by both 3 and 5. So we're going to accomplish the same goal, and I'll test this as well to make sure it's working correctly. And it's maybe a slightly more elegant way to do it, in that I don't have 3 levels of ifs, I only go to 2 levels of ifs. So I'd say if I had the choice of fewer levels of an if statement versus more levels of an if statement, I probably would like fewer. But this should also work then. Let's test the same numbers that we saw before. So comp sci, let's go with 3. Fizz, okay, that's good. 5, I get just buzz. 5 is only divisible by 5, not 3. 15, I get the Fizzbuzz. That's good. 21 is divisible by 3. 22 is divisible by neither, so it just returns the number itself. And again, if I have a number like 30, Fizzbuzz. So I get the exact same results in the end, but notice I did program it a different way. The logic came in a different order. Now, if I made the flowchart with this, I want to do that first and test it. But eventually what you're going to find is as you start programming enough, using enough if statements, using enough loops, you're not going to need the flowchart anymore to help you out. And as the programs start to get bigger, they're also going to be less useful. But at least using a flowchart for now is going to help you plan out how you're going to write the code and kind of pre-test it in the abstract before you get muddled down in the actual coding and the actual syntax of the problem.